students, this video is going to go over how to write half reactions. So we're going to follow these little steps in order to write half reactions. So first you're going to have to identify what is oxidized and what is reduced. How are we going to do that based off of a chemical reaction? You're going to start by assigning oxidation numbers. So you're going to separate the element that's being oxidized into one reaction, and then you're going to separate the element that's being reduced into a different reaction. So you're going to take them and separate them into two different reactions. Now we're going to have to add electrons in order to balance out the charges in those half reactions. And then we want to compare the oxidation reaction to the reduction reaction and multiply them by a certain number to get the number of electrons the same in both the oxidation and the reduction. So let's see how this is going to work. So we start by assigning our oxidation numbers. So lithium here has 0 because it's by itself. Zinc is going to be a +2. Oxygen's a -2. So we have to figure out what this nitrogen is going to be. So total, we've got a +2 from the zinc. We've got 2 nitrogens. And then we've got 6 total oxygens, and each has a -2 charge, so that's -12 equals 0. So our 2 nitrogens have to equal +10. So our nitrogen is going to be +5. Let me erase this down here. So over here on the product side, our lithium is +1. Our oxygen is -2. So this nitrogen in the middle is going to have to be -5, sorry, +5. And the zinc is by itself, so that's 0. So it's oxidized. What lost electrons? The lithium lost electrons. So we're going to have lithium is going to, so that's 0, lithium +1. We have to write electrons in order to balance out our charges. So that's going to be 1 electron here. And then we're going to write our reduction. So we've got zinc with a +2. And then we have zinc with a 0 charge, or 0 oxidation state over here on the product side. So where are we going to put our electrons? We're going to put them on the reactant side to balance out those charges, and we're going to put 2 electrons. And so we have to multiply that oxidation half reaction by 2 in order to balance out the charges, okay? Or excuse me, balance out those electrons. So now we've got 2 lithiums making 2 lithium ions and 2 electrons, okay? Now we did not write the NO3 because the NO3 is what we call a spectator ion. It's not really going to do anything. It's not participating in the oxidation reduction itself because it's not gaining or losing electrons. It's not transferring electrons. So we didn't put the NO3 into our half reactions. Okay? So we're going to write half reactions for each of these examples here. First, we've got to assign our oxidation numbers. So we've got -2 here. We have a +1 here for the copper. We've got -2 for this oxygen, so this nitrogen is +2. This oxygen is -2, so this copper is +2. And this nitrogen is going to be a 0 because it's by itself. So our oxidation half reaction is going to be looking at which element is being oxidized, which one is losing electrons. The copper is losing electrons. The copper is going from +1 to a +2. So we need to add 1 electron over here in order to balance out the charges, okay? Our reduction half, when we look at this, which substance is being reduced, which one is gaining electrons? The nitrogen is gaining electrons because it's going from a +2 to a 0 oxidation state. So we've got to put 2 electrons over here on this side. So that means we are going to have to multiply the top reaction, our oxidation reaction, by 2 in order to get our electrons to be the same in the oxidation as it is in the reduction. Okay? Down here, we've got plus 3 minus 2. We've got 0 and 0, because those are both by themselves. Over here on the product side, we've got plus 3, minus 3 in a simple ionic compound, and we have minus 2 for the oxygen, so this carbon is plus 2. So we're going to write our oxidation half reaction first. So take a look at this reaction, figure out what's being oxidized, and it's going to be the carbon. So the carbon is going from a 0 oxidation state to a plus 2 oxidation state. So we need to add how many electrons to which side of the reaction? We're going to add 2 electrons over here to this side of the reaction. Our reduction half reaction, which substance is getting reduced, which one's gaining electrons? That's going to be our nitrogen. So we're going from a 0 oxidation state to a minus 3 oxidation state. So we're going to have to add how many electrons to which side? We're going to have to add 3 electrons to the reactant side. And so we're going to have to multiply both of these half reactions in order to get the same amount of electrons transferred. So we're going to have to multiply this top one by 3. We're going to have to multiply this reduction half reaction by 2. All right. Now notice that the oxidation half reactions are always going to have the electrons on the product side, and the reduction half reactions are always going to have the electrons on the reactant side. So that's an easy, quick way to tell whether or not a half reaction is oxidation or reduction, where these electrons are. So let's do a couple of more examples here. I'm going to pop up these oxidation numbers here really quick. So we have 0, plus 1, minus 2, plus 5, plus 1, minus 2, plus 5, minus 2, plus 2, plus 1, minus 2. So let's do our oxidation half reaction first. When you look at this, which substance is being oxidized, which substance is losing electrons? That's your silver, because we're starting at a 0 oxidation state and we're going to a plus 1 oxidation state. So we're going to have to add how many electrons to which side of the reaction? 1 electron to the product side. What's getting reduced? The nitrogen is being reduced because it has a plus 5 over here on the reactant side, and it has a plus 2 over here on the product side. So how many electrons do we have to add and to which side? We have to add 3 electrons over here to balance out those charges. Now notice oxidation is losing electrons. That's why those electrons are always over here on the product side. Reduction is always gaining electrons. That's why the electrons are over there on the reactant side. So which reaction are we going to have to multiply, and by how many? We're going to have to multiply that oxidation half reaction by 3 in order to get 3 electrons total being transferred. In our last example here, we have 0, plus 1, plus 1, minus 1, minus 2, plus 1, minus 2, plus 1, plus 5, minus 2, plus 1, minus 1. So we're going to write our oxidation half reaction first. So which substance is being oxidized? Which substance lost electrons? Which one got more positive? And that's the iodine, because it's going from 0 to plus 5. So how many electrons do we have to add? We have to add 5 electrons. And our reduction half reaction is going to be our chlorine, because it's going from a plus 1 to a minus 1 over here on this side. So how many electrons does that mean? We have to add, and to which side? We're going to have to add 2 electrons over here to the reactant side. So that means we're going to have to multiply both of those half reactions. The first one, the oxidation half reaction, we're going to have to multiply by 2 in order to get those electrons up to 10. This reduction half reaction, we're going to have to multiply by 5 in order to get those electrons up to 10. And that's how you have, that's how you write oxidation, reduction, half reactions. So if you have any questions, just let me know. Thanks.